introduce the idea of window comparators. So I thought in this lecture I'll talk very briefly about some problems on window comparators to give you a better feel for how do these window comparators function. So shown here in this circuit is a window comparator. You are supposed to draw the transfer characteristics between the output voltage and the input voltage Vin. Okay, so whenever you are asked to solve window comparators, you will have to see what does each of these comparators do. Once you understand the behavior of each of these comparators, then you just have to perform a logical AND operation to get the output voltage characteristics. Okay, so beginning with this problem, first we look at the I'm going to call the outputs of these comparators as O1 and O2. Okay, and for the first comparator, the input is fed to the inverting terminal, so it's an inverting comparator, and the reference voltage to the inverting comparator is the reference voltages to both these comparators are derived using a potential divider on the supply voltage. So the reference voltage to the first comparator, the comparator above in the upper half, is 2/3 VDD. Now, since it's an inverting comparator, what does this do? Right, a comparator, what does it do? It just compares your input signal to a voltage level, and it will tell you if your input is greater than the voltage or less than the voltage. Okay, less than the threshold or greater than the threshold. Since it's an inverting inverter, what do you expect? When your input becomes greater than 2/3 VDD, your output will go to logic 0. Okay, so since it's a unipolar system, we'll assume logic 0 is 0 volts. So this is how the transfer characteristics will look like for O1. So as I'm increasing my input, initially if your input is smaller than 2/3 VDD, then what will happen? The differential input to this op amp is positive, right? V plus minus V minus is greater than 0. If it is greater than 0, then your output will be at plus VDD. So which is what is shown here. As your input is increased, I'm assuming input is even taking negative values, but even if you assume input goes from 0 volts until 2/3 VDD, your output will be at plus VDD. Okay, so this is at plus VDD. After 2/3 VDD, once your input exceeds 2/3 of VDD, your output will go to 0 volts. So this is how the transfer characteristics of the upper comparator will look like. For the lower comparator, the input is going to the non-inverting terminal. Therefore, it will have a non-inverting non-inverting characteristic. Okay, it's a non-inverting comparator. So as long as your input is less than 1/3 VDD, your output will be 0, right? Because your V in minus 1/3 VDD is your differential input to the op amp, to the comparator circuit. So as long as if this is less than 0, your output will be, your O2 will be logic 0 or 0 volts. If your Vin exceeds 1/3 VDD, then the output will become 1. So this is how the characteristics will look like. It's 0 as long as your input voltage is less than 1/3 VDD. After that it is logic 1, means it reaches VDD. Now you are supposed to find the output voltage. See, once you know the transfer characteristics of the individual comparators, you can simply perform an AND operation. You can just directly perform an AND operation of these two graphs, right? You just have to find when both the outputs are logic 1, then V0 will also be logic 1. So in this range, between 1/3 VDD and 2/3 VDD, both the outputs are logic 1. So therefore, your output will be high or logic 1 in this interval. Outside this interval, one of those outputs can be 1 or 0, it doesn't matter. The output of the AND gate will be 0. Okay, so now you get an idea about what window comparison is. A single comparator will be able to tell you if your input signal is above or below a threshold value. Okay, so it will have a step function kind of a characteristic. A window comparator, on the other hand, will tell you if your input voltage lies in a certain range of voltages, okay, within this window of voltages. So that's hence the name window comparator. A regular comparator will tell you if your input signal is just above this level, above a certain level, or below a certain threshold or level. A window comparator, on the other hand, will tell you if your input lies within a range of voltages. Okay, so hence this, and we just called it as window comparator, and this is the transfer characteristics for the circuit that is shown here in this figure. The next problem, I have just flipped the terminals of input, and here if you see, I have the upper comparator, if you guys recall from the previous problem, was a inverting comparator, but I just flipped. Now I'm applying input to the non-inverting terminal for the upper comparator, and for the lower comparator I'm applying my input to the inverting terminal. So the lower comparator will be an inverting comparator, the upper one will be a non-inverting comparator. Now you are again supposed to plot the transfer characteristics of V0. To do that, we follow the same approach. Find the transfer characteristics of the first comparator and the one on the lower comparator, and you can see that for the upper comparator is a non-inverting comparator, which means the output will go high only if your Vin exceeds 2/3 VDD. So if Vin exceeds 2/3 VDD, the output O1 will go high. Okay, and the lower comparator will remain high only if your Vin is less than 1/3 VDD. Okay, so it's an inverting comparator. The lower comparator is an inverting comparator whose output will be 0 if Vin is greater than 1/3 VDD, and it will be 1 if Vin is less than 1/3 VDD. So the transfer characteristics will look something like this. For the lower guy, it's an inverting comparator, so that's how your characteristics looks like this. The slope will be negative in the high gain region, and it will be high logic 1 or VDD if your input is less than 1/3 VDD, and anything higher than that, your output will be at 0 volts. For the upper comparator, which is the non-inverting comparator in this case, your output will be logic 1 or equal to VDD if it's greater than 2/3 VDD. Okay, if your input voltage level is greater than 2/3 VDD. Now if you see these two plots, right, you can immediately see there is no common range of voltages where both the outputs will go high. Okay, so the lower comparator detects or goes high if your input is less than 1/3 VDD. The upper comparator goes high if your input is greater than 2/3 VDD. Therefore, both the comparator outputs will never go high when there is no region where both will go high simultaneously. So therefore, your AND's output will always be 0. So you can see both your AND gate's output will always be 0, and therefore V0 will always be 0. Okay, so now we'll take the same circuit, we'll take the same circuit, and instead of an AND, the previous circuit here, I'm talking about this circuit here where the upper comparator is non-inverting, lower one is inverting, and replace the AND with an OR gate. Now we'll see what will be the output transfer character, the output and input, output versus input transfer characteristics. Okay, so the first comparator, the upper comparator O1, the output of the upper comparator is O1, that goes high if your input exceeds 2/3 VDD. So this is your upper comparator's transfer characteristics. The lower comparator remains high if your input is less than 1/3 VDD, and it is 0 if your input exceeds 1/3 VDD. Now for an OR gate's output to be high, any one of the outputs can be high. Your OR gate's output will be high. So you just have to OR these two outputs. So between 0 and 1/3 VDD, your output will be high, and after 2/3 VDD, your output will be high if you OR these two outputs. So what do you get? You get a transfer characteristic that looks something like this. Assuming your input signal is varied only till the maximum input voltage is only VDD, this is how the transfer characteristics will look like. Okay, it is just an inversion of a flipped version of the first window comparator. Okay, you just take NOT off. If I take my first window comparator circuit, so let me show that circuit. So the first window comparator circuit here, if I just pass this output through a inverter, I'll get this transfer characteristics. Okay, so this is also a window comparator. It tells me whether my input lies between 1/3 VDD and 2/3 VDD or not. If your input is between this range of 1/3 VDD and 2/3 VDD, your output will go logic 0. If it is outside this range, your output will go logic 1. Okay, so that's it. I just wanted to take a very simple problem to give you a better understanding of what does window comparator, where do window comparators find applications. It finds applications in cases where you need to find whether your input lies within a certain range of voltages or not. Okay, it will be able to tell you the window comparator circuit. You can build it yourself with an appropriate combinational logic to tell you if your input signal lies within a certain range of voltages. Okay, and we took an example and saw 2 examples and saw how to build these window comparator circuits. Okay, so that's it for this lecture. The next lecture we'll look at more details about IC comparators. Thank you.